So now we have a working token contract. So what really is missing? Let's assume we take this and deploy it to the Ethereum network. Now, people are doing token transfers. This works as expected, and people are happily sending tokens. And now we want to develop a nice user interface where we also show to a user his past transfers of this token. And that's when we have a problem. How can we figure out in the UI what is happening in our contract? In our current system, there are two ways we could do this. So, of course, we need some node connected to the network as we discussed. Let it be Infura, some other service, or even your own Ethereum node. Either ways, we have some kind of node running. And now, how can this node figure out when a token transfer happened? You could store every single token transfer directly in the smart contract state. But yeah, it should be obvious that that is incredibly inefficient, gas expensive, and would bloat the Ethereum network. So that's not a good idea. What is the second way we could do this? Well, in our node, we could look into every single Ethereum transaction and then look where the transaction was sent and with which data. So then we could see every transfer function call sent to our token contract. But to achieve this, the node has to look at every single transaction. This might be fine if you run a full node that verifies all transactions anyways, and you only care about transfers happening at the moment. But what if you want to show all past token transfers for a given address? It's extremely inefficient having to process all past transactions. So the solution for this in Ethereum is called logs. Logs are a way to easily identify when a specific thing has happened on the chain. In Solidity, logs can be accessed using a higher level abstraction called events. The idea behind logs is based on a Bloom filter. You don't have to understand the details of this to use it, but it's actually a pretty clever concept. I'll give you the gist of it, and if you're interested, you can read about it more in detail online yourself. Basically, you have a specific length of bits called Bloom filter, where you store information about the existence of some data. Every time you have new data, like X, Y, Z, you calculate different hashes of this data, and then these resulting hashes each determine a specific bit in our Bloom filter. This makes it incredibly easy to then later look up if some specific data exists. You just have to calculate all hashes again, and for each hash you check if the specific bit it maps to is set to 1. If all places have a 1, like here for X, here, and here, then you know the data you are looking for is in there with a high probability. You don't know for sure though, because there could be collisions. In Ethereum, this would be having data that says send transaction to contract with address A with the following so-called topics. Each log can have up to 4 topics. Each topic basically corresponds to a single one here. And this Bloom filter for Ethereum is then not only stored for single transactions, but most importantly, one is stored per block. So it makes it very easy to check if something you are interested in happened in a block, only by looking at the block's Bloom filter. Solidity makes this logging easy to use by giving us an abstraction called events. So let's look at how to make use of this in Solidity.